Okay, so here's an explanation of kinetic and potential energy and their relationship for a falling object. I thought of, falling. Well, so here's the situation. We have Mr. Penguin up here on an iceberg. It looks like the iceberg is 10 meters tall, and Mr. Penguin is going to dive into the ocean. So when Mr. Penguin dives off, he's going to speed up. So we could have velocity vectors that look like this. And as he speeds up, obviously his height decreases. But what we're talking about is a difference between potential energy and kinetic energy. So up here, his potential energy is maximum. He has the greatest height. Remember that potential energy equals mgh. So this is mass times acceleration due to gravity times height. So for the penguin's mass isn't going to change, and the acceleration due to gravity on Earth isn't going to change. But the penguin's height is definitely going to change. So as the penguin falls, height decreases, potential energy increases. Kinetic energy, on the other hand, is 1/2 mv squared. So for the penguin, again, penguin's mass won't change, but as he falls, his velocity is going to increase, and so his kinetic energy will increase. And it turns out that for this system, like the penguin, energy is conserved. And what we're doing is we're neglecting air resistance for the penguin. But if energy is conserved, what that means is that when potential energy is lost, kinetic energy is gained. So the penguin's potential energy is going to decrease, and at the same time the kinetic energy is going to increase by the exact amount that the potential energy decreased. So let's take a look at this numerically. We have a height here of 10 meters. We know that on Earth, acceleration due to gravity is 9.8 meters per second squared. I'm out of space, so I'm not going to write those units. And let's say that our penguin here has a mass of 2 kilograms. And that's actually a pretty light penguin, but this is just a little baby penguin. So baby penguin is jumping off into the ocean. So potential energy, mgh, we have 9.8 times 10. And so penguin's potential energy is, let's see, 19.6. So 196 joules would be the penguin's potential energy at the top of the iceberg cliff. Penguin's kinetic energy would be 0 joules because penguin is not moving. So if velocity is 0, then kinetic energy is 0 just by plugging a 0 into that formula, the 1/2 mv squared. So take a look at what happens. Up here, this is where height is 10 meters. Sorry, that's a little messy. And then here at our halfway point, our height will be 5 meters. Now, you could figure out how fast the penguin's going and whatever by using the old kinematics formulas, like the vf squared equals vi squared plus 2ad, or the 1/2 at squared formula, or whatever, but we're learning how to solve this using our information about kinetic and potential energy. So, by the time the penguin has fallen halfway, notice how if we plugged in 5 for the height, so our mgh turns into mgh, and this is exactly half of this, so half of 196 looks like 98 joules. And because 98 joules has been lost, 98 joules has been gained. So this is the easy way to do this. The difficult way to do this, I'm sure you're like, oh yeah, I want to do that. The difficult way to do this, we'll talk about it. Difficult way to do this is to figure out if an object, such as a penguin, had fallen 5 meters, how fast would that penguin be going? Solve for velocity, then multiply by, and then plug into 1/2 mv squared, and you'd end up with this. So go ahead, try that on your own, and you should get this, and you'll be like, okay, hey, this works. By the time the penguin falls all the way to there's the splash, the ocean, all of a sudden the penguin's height is 0. So 2 times 9.8 times 0, which is 0 joules. So over the course of the penguin's flight, 196 joules has been lost of potential energy, which means 196 joules of kinetic energy has been gained. 196 joules. That's a J right there. So, and again, this is neglecting air resistance. If air resistance played a role, some of that energy would be lost due to air resistance, and this would be slightly less than the initial potential energy. But do you see how these flip-flop? Goes 0 to 98 to 196, 196 to 98 to 0 joules. And that's the way it works. Potential energy is lost, kinetic energy is gained. Now, so here we had our penguin, poor penguin. What do we have? Our 2 kilogram penguin up top. And this was 5 meters, 10 meters, and then the height at the water is 0. So what we're looking for is height and velocity. So we started, our penguin started with 196 joules of potential energy, 98 joules of potential energy, and then 0 joules of potential energy. So the height is obviously 10 meters, and then 5 meters, and then 0 meters. So these are things that we will be solving for. Sometimes you'll know information about kinetic energy, and you'll get potential energy, and then you'll find height. For example, at what height is the penguin going 10.5 meters per second? So you've got velocity, kinetic energy, potential energy, height. When we go to find velocity here, these guys, we're going to use this fact. Kinetic energy is 1/2 mv squared. And, oops, we may need a calculator. So we knew that the kinetic energy was 0 joules up top, so that's easy. Velocity is 0 meters per second. But here things are going to get a little trickier. So we had, what was it, 98 joules was the kinetic energy. So we're going to set that equal to 1/2 mv squared, where our mass is 2. Oh, look, 2 times 1/2 is 1. Nice. So we're going to get velocity is square root of 98 meters per second, and you can plug that into your calculator. I'm not sitting next to one, but it's going to be something like 9.9 meters per second. And then when Mr. Penguin hits the water, we knew that his kinetic energy was 196 joules. So we would set that equal to 1/2 mv squared. And the square root of 196, I think, is 14 meters per second. Notice how, this is key. I'm looking for a different color. Notice how halfway his speed was 9.9, and then at the bottom, all the way, his speed was 14. This is not double this. And that comes into play because this velocity is squared in the formula for kinetic energy. You could also think about it as, for the second half, he's going faster. So here's the first half. Here's the second half. Obviously, Mr. Penguin is speeding up. So for the second half, he's going faster, meaning this takes less time, meaning there was less time to accelerate and speed up. So anyway, an example of how to find velocity from kinetic and potential energy. All right.